Hello everyone, this is Kanan's theory. So today we're going to solve the lead code number 190. It's reverse bits. Uh, so the condition is we have to reverse the bits of the given 32 bits signed integers. Okay, so they are given numbers. Which is example is example one. Input n is equal to 43261596. We have to reverse the number in a bit form. Okay, so we didn't reverse. We should not reverse in a integer format. We have to reverse in a bits. Okay, their own bits. So this is the binary value of the given number. And when we reverse this bits, this one is goes to here, and I mean this zero, the LSB of the first integer is goes to MSB, and consequently it goes to 1 by 1. Finally, to convert this integer, this bit into the integer, we get this 964176192. So this is one of the example, and another example is given. In this example, they are getting the binary value of these integers, and just they are just reversing this bits into the LSB to MSB. Consequently, finally we get this 10737486. Okay, let's see. It's a simple program. I just explained the notepad. I use notepad. Okay. Mm, let's say 14. Okay. What is the binary value of 14? 1110, right? Mm. So 84 means 12. Right, correct. 1110, right? We have to reverse this bits. Okay. This 0 is the LSB of 14 is, I mean, the fourth bit of 14 is 0, right? The 0 is come to the first bit. And the third bit of 14 is 1. The 1 comes to the first bit. And the second bit of 14 is 1, and that comes to the third bit. And the first bit of 14 is 1, and it comes to the LSB. Okay. This is what we get from this 14. And what is it? It's 7. Okay. It's nothing but it's a 7. Okay. So this is what we are going to reach the problem. So here they are given each other 32-bit integers, 32-bit integers. Okay. But I am using the 4-bit integers only. So I just asking the question is basically they are given a 32-bit integers only. They are giving the 16-bit, 8-bit or 4-bit also. They directly give only the 32-bit integers. Okay, we got to solve this in a 32-bit integers only. So first we initialize the result. Okay, that's it. Unsigned int res int res equal to res means result 0. First I initialize result into 0. Why I'm using unsigned int means unsigned it is data range is 32-bit system. Okay, 0 to 4 KB. So signed bit is basically negative value to positive value, but unsigned is 0 whole numbers. Okay, it takes only the whole numbers. It is the negative numbers. That's why I'm taking unsigned int. After that, we have to give for loop for reversing the value. So what I'm going to do here means, first of all, I just take the last bit. Okay, what is the last bit of 14 is 0, right? So 0 is comes to the first bit of sum, right? That is the one. That's the thing we have to do in this problem. And the third bit is 1 is come to the second bit, and the second bit 14 is come to the third bit, and the first bit 14 is come to the last bit. That is the reverse of the numbers, right? So we have to get the last bit, third bit, second bit, and first bit consequently, right? So to do this, we can do this by many methods. Okay, one of the efficient method is AND operation. Okay, so AND operation is used to do efficiently to get the last number, I mean last bit LSB. Okay, so what is the, let's take AND operation by AND of 1. Okay, so I'm doing AND of 1, binary of 1 is 1. Okay, so output of this equal to and AND operation, if both input A and B equal to 1, then only it return the output. Okay, so here the first comparison is 1 0, definitely 0, and 1 0 it goes to 0, 1 0 goes to 0, 1 0 goes to 0. So this 0 0 means 0. Okay, this 0 is basically the last bit of 14. Okay, so after getting this last bit, we have to move this third bit to last bit, right? So to do this, we are doing this the right shift operation. Okay, so what will happen in right shift operation? This shift moves to 0 1 1 1. Okay, this is the right shift of 1, and again we are doing the AND operation. What will happen? 0 0 0 1, and the output is uh, 0 0 0 1. Here we get the last bit of LSB. Okay, so consequently we are doing this. We complete the entire bit in the 14, and and we are getting the last bit of current. Okay, last bit of 14. So we are getting till now we are getting the last bit of each each iteration. Okay, last bit of I mean till now we are getting the each bit in the 14. So next we are going to do the um, then we are going to do the okay, first we write the code loop. I'm using the for loop because they given the size, okay, bit size. So 32 is already given in the question. So I just take that's why I'm taking this for loop. So and then res equal to uh, res left shift of 1 or operation, then n end of 1. Okay, I will explain what it is. Then res equal to less plus and r of 1, then n right shift of 1. Okay, so yeah, this is what we and finally the code is uh, written res. Okay, I will explain this. Okay, I will explain this. So this line I will explain this. Okay, so res means basically we are getting the last bit of 14, right? To store this bit in the first, right, first position. So to do this, we are taking the res. Okay, basically it's a 32-bit integer. Okay, res is a 32-bit unsigned integer. Okay, which means 32 bits are given. Okay, this here we can able to see it's a 32-bit. So this all the 32 bits become 0. This is the condition which is given in the second line. Okay, so this res, first we are left shifting the res. Okay, so what will happen here means uh, res equal to 0 0 0. Let's take 4 bit and give me the example. So that's why I'm taking 4 bits. Actually this is 32 bit. Okay, so rest is 34 bits left. Okay, so first way I'm doing this left shift of 1. Okay, what will happen here in left shift? What will happen? Let's take 0 0 0 0. Left shift also 0. If the rest is 0 0 1 0 means the left shift happen here is 1. Okay, the bits are consequently come to the first position. The LSB is 0, this 0 is come to first position, and the second is 1, it comes to the second position. Okay, this is what it comes from it. And finally this first bit MSB is removed, and another 0 is added to the end of the rest. Okay, this is the right left shift. Okay, first it initially it is 0. Okay, so uh, and or this is the or operation, this is and operation. And operation I already told why it is used. It is used to getting the last bit of the each I mean last bit LSB of 14, LSB of numbers, not of 14. And then we are getting the 14. Here, initially, the bracket rest is 0 and or, and then under operation of n and 14 is 0. Okay, so this 0 is 0. So 0 or 0 means finally the output is 0. Okay, the OR operation, OR operation, 0 1 means it gives 1, 1 plus 0 means gives 1, and 1 1 means 1. Only the 0 0 occurs, it returns the 0. Okay, this is the OR operation. Okay, why we are adding this means we are adding the last bit to the 0. Okay, last bit to the 0, then whatever the value in the last bit, it directly return to the uh, directly added to the result. Okay, that's why we are adding this last bit to the 0. Okay, so I just explained throughout the iteration what will happen in the first and final iteration. Okay, iteration 1. And I'm taking the example n is equal to 14. Okay, so then first the for loop is checking I is equal to 0, I less than 0, 32, condition satisfied, then it goes to the loop. Rest equal to less than, I will explain this thing. Okay, result is 32 bit. First rest is less than 0. Okay, so initially rest is equal to 0, 0, 0, 0. Okay, so this left shift of 1 makes it as again 0, 0, 0. Okay, there is something in that bit, though that's why it returns only the 0. And this n and 1 gives the n and 1 gives the uh, 0, uh, 0, 0. This okay, fine. 14, the binary value of 14 is 0, 1, 1, 1, 0, right? So this n and 1 gives the 0, 0, 0. Okay, so finally we are adding this 0, 0, 0. Okay, the output is nothing but it's actually finally 0. Okay, so this output is stored in a res. Okay, it's a result. Output is stored in result, it's 0. This is what is happened in a first iteration. And iteration 2, n is equal to uh, n right shift of 1. Okay, right shift means this 0 is the 0 will be leave in the entire bits, and another 0 is added to the MSB side, this side. Okay, this is the right shift of I mean, this is the right shift of 14. So 0 0 1 1 1, this is the right shift of 14. So then the rest is again the rest is 0, 0, I mean rest is 0, 0, 0, and it is stored in 0, 0. Then n and 1, it gives to 0, 0, 0, 1, because the LSB of 1 is LSB of n is 1, right? So it gives to 1. And operation, why you are using and operation to get the final LSB value. That's why we are getting this LSB value. Okay, to adding this, what will happen here? 0, 0, 0, 1. Okay, so then okay, this is what happened in iteration 2. Then iteration 3, yeah, again the n is left shift or right shift. So what will happen there means 0, 0, 1, 1. Okay, this is the right shift of n, and the result is left shift, right? Result is left shift of 1. It goes to 0, 0, 1, 0. Okay, so this is the iteration 3 we get from the result. Then n and 1 gives n and 1 gives 0, 0, 0, 1, because the last bit of n is 1, right? This is iteration 3. And finally 0, 0, 0, 0, 0, 0, 1, 0, and it gives 0, 0, 0, 1. After doing the OR operation, what will happen here means uh, 0, 0, 1, 1. Okay, so sorry, this is not first iteration is not left shifted. Okay, 0, 0, 0. Okay, So till now the iteration 3 is completed, and then the iteration 4. Iteration 4, iteration 4, uh, n is equal to n is left n is right shift of 1, 0, 0, 0, 1, and then yeah, then resist left shift of 1. Here the resist, this is the left this is the which means the result. Okay, left shift of 1 means it goes to 0, I mean, 0, 1, 1, 0. Okay, another 0 is added at the end of this rest. And then we are doing the OR operation. So then n, okay, n, n and the operation of 1 gives to 0, 0, 0, 1. Why this 1 occurs? Because the LSB of n is 1. So then 1 occurs. Then it moves to 0, 0, 0, 1. Finally, what's happening here means 0, 1, 1, 1. Okay. So till now the entire reverse operation completed. So uh, so the output is result equal to 0, 1, 0, 1, 1, 1. This is the output of this code. So here the input is 1110. Okay, this is the input. It's nothing but 14. Okay, so the output is 0111. What is this? It is 7. Okay, we don't need to tell it. So we have to return this 7 value. Okay, so this is what is we observed from this code. So iteration 1, I just give the overall explanation how it works. In the iteration 1, what is happened here means first it right shift. First it left shift the result. Okay. So to do the to do the addition operation, we have to give a space, right? That's why we are doing the left shift operation. Then we are we were taking the AND operation of AND operation with 1. Uh, I mean n with AND operation with 1, so it gives the LSB of the n, and then we are doing the OR operation to add this. Then finally it goes to the right shift of n and left shift of or yes result. Okay, so this is how the code works, and I just run this code. um, okay, I think it works, but the time complexity takes a lot. So yeah, and it takes 2 milliseconds for doing this and to run this code. So fine, okay, it's easy to understand the concept of it. So this is how the reverse bit operation works. So I just explained again overall. First, we were giving the initialization of rest with nothing but result by using the unsigned int. It gives the 32-bit 32-bit integers. So here the given input is 32 bits, so that's why we are doing this unsigned int. Then we are giving the for loop and give the condition I less than 32. Why I'm giving 32 means it is given the question 32. That's why I'm doing this. Then the result is equal to result left shift of 1 or n and 1. This n and 1 gives the LSB of n, and the result left shift gives the is to store them store the LSB in the first bit. So to do we are doing our operation to store the value into the first bit. Then we are giving the right shift of the n because we already taken the LSB of LSB of n, and it's stored in the result. Then when we don't need that value, so that's why we remove that LSB and we move the previous value into the last bit. So finally, the code repeated continuously to get the result. So after that, it shows all the binary value and it return the result. So this is how the code works. Thank you for watching. So I think I will understand. I will attach this file into that below video, so you can get it from to understand deeply about how it works. Okay, thank you for watching this.